Hi everyone, we're Group 42 and we're working on a capstone management app this semester. My name's Kaya.
My name is Mohammed.
My name is Shilp.
My name is Eric.
So the problem at hand that we have is that Capstone is a large-scale event run by students and professors. Because of this, there are multiple facets, including planning, organization, and providing constant updates. There is a need for constant communication. However, communication is scattered across multiple platforms, including Sakai, email, and Microsoft Teams. This makes it difficult for faculty and students to keep up with the constant updates and announcements. Currently, there is no central hub to streamline all of these processes involved. Our team would like to provide a solution for all of this.
So the proposed solution incorporates four main aspects into one capstone management application. The first aspect is for students. So students will be able to form teams on here and provide project updates. Faculty and advisors will also have access, and they'll be able to manage the course and give announcements, as well as judges. So this becomes a central place to view all the teams and their projects and updates along with it. So it becomes a lot more convenient for judges to view the projects as a whole. And finally, the informational side. So with the application, we can keep all the data and run very informative reports. And additionally, because this is geared towards the course and the event specifically, we can create many features that are designed specifically to make life more convenient with this problem. So that was the application as a whole, but our scope of work was kind of just setting the groundwork for this application and creating some core functionalities. So when setting up, we decided to create a web application for ease of use. And as Mohammed mentioned, this becomes a central portal for communication. So all students, faculty, and judges will have access to this. And we want to focus specifically on the student side functionality for our project.
So here are some of the main functionalities that we originally had in mind. We had three types of users: student, faculty, and judges. Once we did more research, we decided to focus mainly on the student user functionalities for our scope of work. So the functionalities that are in bold are the ones that we decided to work on this semester. Login and register would be working for all three types of users. Team formations under students would be able to create, join, update, or delete a team. Uploading material would be able to upload material such as presentations, request forms for equipment, and posters. Also on the main page of our application, there would be a list of past presentations and posters.
In terms of the actual creation of the application, we knew from the start that we were going to make a web application, easily accessible to students who may not have smart devices. So let's move on to the tech stack for the web app. First, we decided to use React for the front end. As of today, the two biggest front-end frameworks are React and Angular. However, as most of our team already had some experience with React, we decided on using our previous knowledge with this framework to begin working on the user interface of our project. Mohammed will be explaining more about React later. Next, we decided on using Spring Boot for the backend. The main reasoning for this was the accessibility and convenience. Being a production-ready framework, Spring Boot provides a lot of tools to reduce the configuration time of the application. For example, if I was to open an empty Spring Boot project, I would be able to run it and deploy it on a server. What this means is that while the product may be empty, a lot of the backend work has already been taken care of for us, saving us a lot of time. In addition, API development in Spring Boot's framework is extremely intuitive and straightforward with the use of their annotation feature. Furthermore, another added benefit is that in working with Spring, we also gain access to their Spring security feature, which we had begun to use in developing functionality for our login and authentication services. For our database, we set up a MySQL workbench. Given that a critical feature of our application is the creation and maintenance of a database, we believe that a NoSQL database, such as MongoDB, would not be as flexible as using something such as MySQL, which is an SQL language. In terms of cloud hosting, we decided on Amazon Web Services EC2. While another option we had was AWS Lambda, we thought that Lambda's event-triggered billing model was incompatible with our application. This is due to the fact that many students could be accessing our application at all times throughout the day, meaning that EC2, which provides a continuous uptime billing model, would be more cost efficient and would more adequately suit our purposes. To begin our work, we first split up into two teams, our front-end team consisting of myself and Mohammed, and the back-end team consisting of Shilp and Kea. For the front-end portion, our responsibilities revolve mostly around working with React, designing and creating the user interface that students would see when they open our application. For the backend team, their job was to set up the EC2 instance and create the database in MySQL. Additionally, both teams worked on the backend API requests with Spring Boot. Being that there were two teams, we thought it best to split up the work into two separate GitHub repositories, one for our front end and one for our backend. This way we could keep the organization of our file structure clearly separated, and it would be a lot easier with less people working on a single repository. In terms of hosting on AWS, we were able to separately host the front end and back end on separate EC2 instances, but ended up having trouble configuring them to enable communication between these two services.
So here's our database design. So the student table would be populated from the data that we would receive from SOE or Rutgers. We would use the fields grad year and grad month to determine which capstone year a student would be eligible for. And then each year would have its own capstone, inventory, judges, and advisor table. In each capstone table, a group number is added every time someone creates a new team. Each student will be added to a team once they input their access code and the group number. These are given to the user who creates the team or to the user once they join. As students will be adding and changing teams a lot initially, the group numbers will easily go over double digits. To keep the final numbers incrementing only one at a time, we'll be using team numbers. These are only decided and incremented once teams are finalized. Each group will also have an advisor. We will use the advisor's net ID to associate each member of the team with advisors. For inventory, each equipment requested will be associated with the student's RUID. And for each capstone year, we'll also be keeping track of judges and their basic information, such as their names and emails. Here's an example of a student database table. So as you can see, someone that graduates in May of 2020 will be doing their capstone project as a class of 2020, but someone who's graduating in the fall semester, such as like December 2021, they'll be completing their senior design the semesters prior, as this is a 2-semester project. Here is an example of our capstone table. So this is just more mock data. Currently, all of this data is entered manually by Professor Godrich, but our app will do that automatically. Here you can see the group numbers go up over double digits. We would need both access code and a group number to join a team. So group 78, for example, doesn't have a team number because they don't have an advisor yet. Once they finalize, they'll be given the next team number.
So this is the setup of Spring Boot. It's the general flow of like data and the information. So you can see it starts off with the front end, making an HTTPS request to our controller. The controller will manage all these requests and direct it to the correct services. And these services is where essentially all the logic gets implemented to manipulating and organizing data. So the service layer specifically will be creating, reading, updating, and deleting information from the database. This also deals with the models. So the model is just data that we retrieve from the database. So this is the flowchart of the login. You can see it starts off with the front end. The user will enter their credentials. The error handling is done in the front end. But once they send a successful HTTPS request to the back end, the controller will recognize this request and pass it along to an authentication and authorization service. Spring already has a built-in security service called Spring JPA that manages this. So users can securely log in through this. And there's two options. Either the login fails, which then will be reported to the front page, or if the login is successful, we can identify the type of user that's logged in based on our data, whether it's a student, faculty member, or a judge, and direct them into the correct landing page after they log in.
So here's a registration flowchart. So a user will initially go to the register page and submit their credentials. If their requirements are met, then the data will go through Spring's controller and authentication and authorization service classes to securely place that data in the database. If registration fails, the user will be redirected back to the register page. If it's successful, they'll be receiving an email confirmation If they reply, their account gets activated. If they don't, their account will be inactive until they click on their link.
One of the main functionalities we wanted to implement was team formations. So this is kind of the flowchart and the logic for how that would happen. So you can see once the user logs in successfully, they have two main options. They can either create a team or join a team. They fill in the specific required information and make a HTTP request to our Spring controller. This Spring controller will use our service to modify the team data that's within the database. So you can see the database deals with the teams model, and depending on the type of request, it'll either create a new team, which will then generate a new group number that others can use to join that group. Or if they click join a team, then they enter in the group number that was previously given, and they'd be added to that group, which all the data will be saved back into the database, and then the specific information will reflect on their updated page. So this is some example of the code that we used. So this is a controller for the home page. So once anyone logs onto our website, they interact with this controller, and you can see some of the API calls that this controller specifically handles. So based on the type of API call we get, we can handle things differently. It makes the organization very intuitive and functionality implementation intuitive as well. And at the bottom, you can see how it also handles the login. So what this would do, this API call would use the login service to verify if the user is able to log in, get their credentials, etc.
So here is an example of a user model that allows us to work with data in the database. This is a user class, and we can use its objects and getters and setters to retrieve and store data from the database tables.
And this is an example of a service. So this service specifically deals with user data. It'll get all this data from the database, and you can manipulate its fields, such as is the account active or inactive. And this is how we plan to implement all these types of functionalities. So you can see how the overall flow of Spring is pretty intuitive, and services are very essential to this part. And we had other services that managed creating and reading data as well.
So for our front end, we decided to use React because of its various benefits. React is component-based, meaning that once you create something such as a button or form field or header, you can reuse that throughout your entire application. This saves a lot of time in writing code. React is high performant, so it loads pages really easily and handles multiple requests at the same time. React is scalable, so in the future, as this project gets larger and larger with more features, React will be able to handle that. It's open source, so there's a lot of resources and constant updates to React. It's ease of use. There's lots of documentation, so it's very easy to use. And if we have any questions, there are lots of resources available. And then finally, React has very good developer tools for debugging and testing our application. So for our project, this is the homepage that we created. We wanted to incorporate previous year capstone so that when anyone comes to this, they see basically what this application is about, ECE capstone, and then there are links provided to view capstones from all the previous years. At the top right-hand corner, there are options for people to log in and register. And then for our register page, we have the various form fields that our backend needs. So we have first name, last name, RUID, and email. We cross-check the RUID to see if a student is eligible for capstone. If they're eligible for that current year, they will receive a temporary password in their email. If they aren't eligible, we have error handling that displays to a user that they are not eligible for the current year, or if they have already registered, it will also notify the user of that. Once a user receives an email, they can now, they'll be redirected to the login page where they'll be given a temporary password. All students will be using their NetID and password to log in. After initial login, they will be asked to change their password. After that, after subsequent logins, they will be redirected to their profile page. So this is the initial profile page when a student is not yet part of a team. After their first login, a student will be here. They will be able to change their profile picture. Their name will be available. There will be announcements at the bottom for any updates in regarding to Capstone. And then on the left-hand side, students have the options to either create a team or join a team. Now, this page was designed as these features were not implemented yet. But we had already had the groundwork laid out. So this was the design of someone's profile page. And as you can see in team information, since they are not part of a team yet, there's a red notification that they have to join a team.
So moving on to the landing page, once a user does have a team, you can see that as soon as you log in, you can verify what team you're on and see all of the members of your team, as well as some other general information just in case you forget something like a member's email or your team number. Additionally, now that you have a team, you now have the option to leave the team or edit team's info. Additionally, view more info will redirect you to a page where you can see more project details such as advisor information and a general description of your project. The overall goal of these pages were to be as straightforward and uncluttered as possible, so we can make navigations for students and advisors or anyone using the app as easy as possible.
So we had certain functionalities left to complete, one of which was team formations. We described that in a flowchart before. After that, we work on other functionalities such as uploading materials for students, so such as presentations, posters, and forms.
And finally, taking a step back into the project as a whole, this was just kind of the initial setup of the project and some core functionalities that we described. But there's a lot more functionalities for faculty and judges that still need to be incorporated in future semesters. And the main part of this is the specific features that we can really implement to make this whole course and event self-managed, essentially. So that's the final goal of this application as a whole. Thank you. Are there any questions?